Hey y'all, uh, welcome back to our T1 Presenter channel. So today I'll be concentrating on one of the use cases customers asked us, which is showing uh, bigger machines like a robotic arm or exclusive machines for teaching, which are kind of hard to get by in real. So in this presentation, you'll be seeing about industrial robots and its applications in short, and you also see a model of an industrial robot. Okay, let's go into the presentation. So this is a automobile manufacturing robot. So if you are in automobile industry, you will come across these kinds of robotic arms frequently. So I think this is a Kuma robot, and probably it might be used for welding purposes. So let's see the robot. Okay, I think right here, review. This is where it will actually we can put a welding machine or a camera here. So let's see about the use cases of the robotic. Okay. So industrial robotics will cover what are the present and the future trends and the design considerations and safety practices. So the history and the evolution of industrial robots. So in the early days, robots were primarily used for very simple tasks in manufacturing. And later in 1970s to 80s, we were seeing computer integrations into robotic systems. And now industrial robots are highly advanced to the extent of having collaborative features and capabilities with humans. So typically when you go into an industry, you actually learn to collaborate with the robot. With the advances in artificial intelligence and sophisticated sensors, it is vital that people know how to use robots and about speed. A robotic manipulator discipline. This looks like the robot that we have already showed you. So primarily, where the robot will be used. Kinematic design, trajectory planning, feedback control, and programming languages in short. So when we say kinematic design, it says about how the robot structure is and what are the capabilities of it. Trajectory planning is how you plan a robot to move in a certain directions so that it doesn't go and buckle up in an obstacle, and you should have a desired movement so that if you place that inside a factory, it doesn't go and hit another machine or another part which is nearby. And feedback control. So using sensors, the robot can receive feedback from the environment. So the typical use cases is vacuum cleaner robots or automobile robots which move inside the factory. So they use sensors to identify hurdles or obstacles so that it doesn't go in that path. And lastly, programming languages. So programming languages will be used by engineers who want to program. So this, what you see on the figure, is the design of the robot that will be showed. Yes, applications of robotics. Robots are used in all the applications today, from manufacturing to logistics, healthcare, agriculture. In every field, robots are being used. Even today, robots are being deployed, like your car is even a robot. Robots are in every field, from automated controllers to automatic vehicles, electric vehicles. So many applications use robots. These are some of the use cases. Yes. So what are the future trends and advancement in industrial robotics is now we have come to human robot collaborations, and going forward we have more AI integration into robots. So robots becoming more intelligent, they learn from the data and adapt to the changing environment. So as I told earlier, one best example is self-driving cars. They learn from the data and adapt to the changing environments. And even industrial robots where human interaction is limited, like space sciences, it is vital for the robot to learn and adapt to the changing environment. So robotics. So this is one of the use cases that you can have with our immersive presenter, that if you want to simulate or show a highly advanced robot or something, you can contact us and then we'll help you put the software model inside our product and you can explain this in your class and get benefit out of it. Thank you.